Okay, I am starting recording now. Okay.
Yeah.
So here data constraints means so all that rules should be applied. Okay, that is the constraint. So they will ensure that your integrity is not challenged or modified. Okay, you will have these are your main constraints here. Let me zoom it. Okay, zoom it little further. Okay, so you have not null, one is constraint. Okay, this is constraint mean condition. Okay, so column must not contain any null value, that is number one. And number two is unique, like your id should be unique, it should not duplicate. Okay, if it is duplicating then you will reject it, so that your data is integrated. Number three is your primary key. Primary key should not be null. Okay, and it should be uniquely identified. And foreign key, it should be linking between the columns, or you need to have a reference. Okay, and there will be logic in between that. So you need to apply the logic. So if you are doing something or some operation, you will be doing the logic. So these are all will apply for your constraints. Okay, that is your constraint. Okay, then you will have SQL join here. Okay, so join will be combining two or more tables. Okay, which will be with the related columns between these two. Okay, they allow you to.
Please maximize the image.
Okay, view. So you have here inner join. Okay, so everything from table A that exists in table B means both, in both you should have union here. So that is called inner join. Okay, so then you have left join means, so where you have data, all the customers, even they have not ordered anything. Okay, show me all the customers. So here who has ordered and who has not ordered. So you are taking all the customers. Okay.
Yeah, includes. Yeah.
Right join is show me all the orders even if you don't know who the customer is. Okay. One customer will order one or two orders. Okay. I don't care how many one customer is ordering. You just show me the orders there. Okay. That is one. Now we'll scroll. Now full join means you are just combining everything here. You show me the orders and you show me the customers. Both you show me. Okay.
Yes.
So let me drag
So you
this
can
one.
minimize this because it is full page.
Okay. So let me do this. It's hanging. It says.
So two times is inner join.
Sorry.
Two times inner join.
Yeah, that got this one. Okay. So my VMs are taking up a lot of space. Let me shut it down, this one. Okay. So this is your full join. Okay, both are overlapping and you are collecting all the results from both of that. Okay, this is called union. Okay, so you are simulating the union here. Now you have cross join means you are combining every row, okay, with every from first to second row you are just doing a cross reference, okay, from single row to everything that is present on your left, and from right and left you are just joining everything, okay. So now you have
Cross join means
uh,
cross join. Right and left, you are joining everything.
yeah, you are joining everything now, okay, pairing it, okay, every you are pairing every customer with every single order, okay. So if one guy has ordered it, you are checking with everybody. Let's say you have 100 customer, you have 10 orders, every order you are checking with 100 customers, that is your cross join, okay. Self join is, it is like a you are joining with the regular table, you are joining your table itself, like you have employee number, you have manager id, you have all other things, you are just joining those tables within that self. So that is your self join. So those are the join parts, okay. So then we will move it into, if you want best practice, you can see that, okay. Inner join records that matches in both tables, then you are doing a inner join. Left join means all records from the left table matches from right, okay. So this is vice versa. So full join means all records from the both tables, you are just doing a union here, okay. Cross join means you are doing a combination of both tables, okay. So those are the best
I understood. Cross join is combination of both tables.
so you are doing a combination here, okay, from both the tables, okay. Let's say you have cross join here, okay. So let's say you have order here ls, okay, all the orders here 101, 102, 103, 104. Then with Bob also you are doing the same thing here, okay. Then with Charlie also you are doing the same orders, so you are repeating everything, okay. That is your cross join, okay. So now we will come to functions now. So what is the function is like you have written some code, okay. So I want to use that particular function, I don't want to rewrite everything. So what you do, you will just recall that function and that will be done. Let's say you have created one die, okay. So if I put that die, you will get that shape, okay. That is how a function will be defined, okay. So if you want to do some calculation, you will just call that function. Once you call that function, you will give that input. So based on that, that die will perform and you will get that output. Let's say you want to get a cap of a particular size and a particular model. So you will just give the raw material, that die will give that output. So the same thing will happen with the SQL function also, okay. So if you want to perform any mathematical functions, you will call these functions. So this will be performed all that mathematical functions, okay. See you are doing a uppercase here, upper, lower, then you are trimming it, substring, all that you are doing. Then numeric, date time function, then you are doing all the statistical here, sum, average, count, all that you are doing, you are not calculating anything now, okay. So now you are doing a ranking also here based on the values,
Window function.
yeah, okay. Then you are doing a conversion here and conditional also by choosing the logic here, okay.
What is your functions?
Sorry,
Window functions.
window functions.
Yes, window.
So these are the advanced one, like you want to do a ranking. You want to do the select the values. Let's say you have 10,000 students. Okay, you want to do a ranking. Let's say in 10,000 students, almost 100 people got the same marks. Okay, how you will do the ranking now? See, out of 20 lakhs, let's say 20 lakhs, okay, 10,000 got a same amount of marks. Okay, now how you will do the ranking? So you will do a value here. You will give a dense rank. You will give that specific priority. Okay, this question will have these many points. This question will have these many points, like that. You will segregate it, and then you will calculate with the age also. What is the age of the candidate? Okay, so those are all, you will put that parameters, and then you will do that functions here. Okay. So now you have something called cast, means, so instead of typing a text, he has given some integer or something like that. So you are calculating that and converting that. Okay, that is your conversion.
Hello.
Yeah. Yes.
I can hear you.
Now.
Actually, yeah, now, yeah, I could not hear you. There was a network.
Now.
Can
Now.
you repeat again?
Okay.
Now I can hear you. Please repeat again.
See, if you are typing some characteristics, okay, like instead of integer, he is typing some string. You want to convert the characters, so you will use this cast. Okay, or you want to convert the null values. Okay, instead of null, he has not given null. You will select n by a, so that there won't be any null here. Okay, so this will be all used for programming and logic. Okay, then you have something called user defined function. So I want to do some calculation, some customized function I want to write. So then I will be using this user defined functions. Okay, these are all the functions that you will be using in. So now you see the examples here. What are these examples? You see, so you are doing a case conversion here. Okay, so let me take out this navigation. Okay, so you are doing it here like this. So from hello to uppercase to lowercase to upper to lower, then you are taking the length. Okay, then you are doing a removing the leading or trailing spaces. Somebody has given lot of space, you are removing that space also. And now you want to remove that particular year, or you want to trim the text. So you will be doing that substring from that particular text. These are all manipulating. So this joining and replacing also we have done it. First name and last name, all that. Okay. So then you have user defined functions in that also. Okay. So you have numeric now. These are all the functions, mathematical functions. You just give values here. Square root 16. All these if you give, it will come automatically the result here. Okay. These are your numeric expressions. Okay. You are transforming all this. Okay.
You just will add more power. And
Yeah.
it will automate.
Now you are doing the date and time functions here. Okay. So you want to
Date
extract
and-
the year here. Yeah.
Yes, yes.
So if you do
This
it,
date, yeah, this date, sorry, date with year and the month, right?
yes, you see the result here.
Like you date of birth, date, month, and year.
Yeah. Okay. Same like this. So you are doing the conversion, that is graphical here. So if you do this, this will be your result here. Okay. So now you have conversion and conditional here. Okay. So you convert it, okay, cast 1 2 3 as integer, okay. So now you are converting a value to its type, okay. So instead of text, you are converting as a integer here, okay. So if he is giving null values, then it will come as like this fallback, okay. It should not be null here, okay. So now you are doing a function here. If condition is true, then you do this, okay. If age is greater than, then you do adult or else minor, okay. So case also like this, advanced conditional case when age less than, like that, okay. So these are all your conditional statements.
So what is the process it will return
Okay, what is that?
fallback? This
Okay, fallback. Okay, let's me. Okay, you take this here. Okay, you are handling null values here. Okay, so if he is giving null, okay, you just tell this is fallback, means I am not going to produce any output for this. So I will just remove this column. That's it. That is fallback. Okay, that is what you will be doing. So these are all the conditions, if and but, then case. If this is the case, then that will happen. All that, these are all the constraints here, okay. Now you have window functions, okay. So just like you are selecting the department here, like that you are doing the ranking here, first, second, third, based on the salary, all that, employee input, all that you will be selecting with the queries here, okay. So now you want to do some user defined functions. So you want to do some
is important.
calculation, you want to do some tax calculation, okay. So you define some something here, okay. So you have created your own taxation, okay, like GST, not GST, like ITR filing, okay. So you will ask all the input. So you will ask 12 questions, okay. Let them fill that data to you, okay. You will ask, okay, you just submit this query. Once they put the data, they will tell, you will give the output, okay, this much you can claim the tax back, okay. So you created a formula, all that you done it, and then it is giving you output now. So that is how you will be defining your user defined functions, okay.
I did not understand actually properly.
See, you want to calculate the taxation, okay. So you know the taxation, right?
Yeah, I get it. Yeah.
So the salary range 10 lakhs, 12 lakhs, 15, 20, 30, 40, all that, okay. So based on the salary range, you will create a function here, okay. So you will create a function and you will give one file to them, or you can ask, okay, you give me your salary and your saving and your rent, you give me all the 10 values, okay. You will take the 10 values and you will put that in your formula, okay. This is your user defined function. You only created this formula, okay. Nobody has done it. You created this formula, okay. Once you give that value, that tax you will come, how much tax you have paid, this is how much you can reclaim it, okay. So you made this formula, this is not there, okay. This is user defined function, okay. So you are calculating all this function, you are calculating input, then output, all that procedural logic, then you are applying, then you are doing all that, okay. Now you understood.
Yes.
So now we'll go with the views now. Okay. So view is like just like your virtual table. Okay. It is like a temporary table. It does not store any record here. You will just view that data. That's it. After that, it will be queried. That's it. Your query will be saved. Okay. That's it. The result you will get it. Okay. So when you do a query here, let me show you this diagram. Okay. So when you do a query, okay, this is how it will work. First, why it is taking, if I am zooming, it is taking time. Okay. Okay. So once you do a query, okay, it will look up that table here. Then once you do select all that, it will give you that result. So this is your physical table and this is your virtual table. Okay. This is data generated, which will be dynamic here. Okay. So no disk space will be used here. Once the view is done, this will be deleted. Okay. You will no longer require this. So whereas physical table, it will store the data permanently on the disk. Okay. So you want to do some querying. You need to do lot of querying. Then you will have a views for that. Okay. So that you get it for performance. That is why we will use a view here. Okay. So creating view, then you are querying a view here. Okay. You will just use this virtual table. Instead of physical, you are using virtual table. So then once you have done the view, if you are no longer required, you will just remove that view. That's it. Okay. So which will enhance your performance. That is the use of your view here on the table. Okay. So you have normally you have 3 use cases for using the SQL view. Okay. First one will be your simplification. Okay. So I want to just have a simplification of all the tables so that I can view the overall data. And then one more view is I want to see the access control. Who is having what access? Who can have what sensitive information, all that. So for protecting security, you will put it the views also. Okay. And for consistency, okay, you need to have centralized view. For that also you will be using the views for that. Consistency view. Okay. So you see here view versus table here. So in table all the data is stored on physical disk. Okay. So it will store only the query definition. Whatever you do the query, it will give you only that information. It does not store any data. Okay. This will be very slower. Okay. It will be writing on the disk. It will just read it. Okay. It will be instant. So here you need to do a modification. Okay. So you need to do insert, update, all that. Here you are just reading that. You are not doing anything. If you are doing any other activity, then it will not be called as view. Okay. It will be called as this update, insert or delete. Okay. Then your freshness, this is static. Okay. It will it is updated until it is updated. This will be always fresh. Okay. So you have a limit. Means you will be querying every time. Okay. If you run it now, one query, after 2 seconds if you run it, then it will fetch that data again. It will not take that static data. It will go back to the table and it will go back to the disk and it will fetch the data. Okay. Now you have something called indexing. Indexing is like just like think about your book. Okay. So just like how I am navigating here, this is my index. Okay. So I am navigating so that you can tell any chapter, I can just pick it up. Okay. If I am indexing with page number, it will be hard for me to navigate um, any topic. So this is how the index will work. It will just pick it up. So it will have index. It is in a structured manner, okay, which will speed up my retrieval speed. I can see whatever it is happening here. I can just pull up. If you are asking, okay, query information, if you are asking, or if you are asking capstone project, I will just pull it up like this. Okay, I will take this one. Okay, this is your capstone project. Okay, so it is in 456. So now if I click on here, this is SQL database, okay, on 223. This is subqueries, this is 213, okay. This is index, okay. I will just do it. So this is also how you will be taking up the performance, okay. If you are indexing it, you will have great performance. So that is why I have installed a everything on your laptop, so that it start indexing. If you just type it, it will automatically show you that file name, because it is already indexed everything. You will have a sequential scan, okay. Every row it will do a scan, okay. If you don't have index, it will read it every row. If you do index, it will just pick it up, okay. So now let's see how that indexing will work, okay. So you have here before and after, okay. So you are indexing all the users here. So users. So now you have indexed orders. Now you have index. Now you are indexing products, and then you are selecting the product from sales also. Okay, it will just pick it up, because you have already indexed it. You don't have to search it. It will improve your speed, which will improve your 70% faster. Now this will be 80% faster, okay. You see the performance impact. So if you are filtering it out with where, it is 60%. Now if you are filtering it with logs, okay, 85% it is improved. That is what your indexing will do. Now we will see what type of indexing you will have. So you have clustered indexing, non-clustered, unique index. All these will have their own limitation and best use cases, okay. So let's see how they are used, okay. B tree is, this is one type of indexing, okay. So where it will searches insertion and deletions. So this is best used for between or sorting most primary keys. If you are using a large data set, okay, so then you will use this type of index. Now you have a you need to physically order table here, okay. You need to do sequential searching, okay. You will do clustered index, so you will have drawback also, okay. So if you are doing clustered indexing, so the data inserting will be slowed here. Then you have non-clustered, okay. You will have separate structure with pointers to data rows, okay. This pointer will go here, all that, okay. So this is you have drawback for each and every indexing, okay. So based on your requirement, you will be doing a indexing based on your requirement, okay. If it is large queries or ranges, then you will be doing covering index, okay. So
cluster index, it it's like a insert and whatever it's insert.
See, whenever you, if you are doing a primary clustered indexing, okay, if you change any data, if you insert any data inside your table, okay, then your entire table needs to be indexed again. Okay, it will read the entire table. Okay, it will slow down the data if it is inserted, if data is inserted. Okay, so if you are doing a unique index, okay, it will reject your duplicate inserts. Okay, so it will based on your requirement, you will select the index type here. Okay,
And non-cluster, it will not navigate all.
yeah, with it will be pointing to data rows, non-clustered. Okay,
And multiple also allowed.
yeah. So let's see what are the benefits here. Okay, of of your indexing, creating indexing, and what will be the cost here. Okay, so if you are creating indexing, okay, single column index, okay, so you are creating this index, okay, what will be the cost? Index on a single column, example email. Okay, so your composite indexes on multiple columns, so your multiple columns you will be indexing it. Okay, so then you are creating a unique index. Okay, it will ensure the unique value in the indexed column. So whatever you have indexed it, it should not have a employee ID same. Okay, so employee ID should be unique. So you have already indexed it, it will automatically reject. If somebody gives the false employee ID, it will automatically reject because this is already indexed. I cannot check it. I know this is wrong. Okay, so now you are indexed with included columns. Okay, so if you are including columns, then the syntax may vary here. Okay, so that will be your cost and risk here. Okay, then you have these are all your drop. So drop an index. If you are having, what is the benefit? So you are incorrectly dropping an active index can slow your specific reads until it is created. Let's say you are you want to drop some indexes. Okay, so once you drop it, your performance will increase. Okay, or it may decrease it if it is looking for that particular active index. Okay, so if you are let's say you want to show the index, okay, so it will be benefit for you. Okay, if you are selecting the customer data, now and then you are often selecting the customer data, it will be beneficial for you. Okay, if you are selecting it from Postgres, okay, from all that you are selecting it and you are using the custom all the variables, then it will not use the index here. If you are doing a wildcard entry, show index from customers, that's it. So because that is present in index, it will just throw, okay, you take it. Okay, so index only if it is required or highly selective, or if you want to frequently using that. Okay, then only you use the index, or else you will not use the index. It will consume your disk space and it will consume your lot of writes. It will keep on writing it. Okay, you are indexing on the database. Okay, So what is the benefit of read speed versus write cost? So if you are reading,
Okay, so you skip something after the first one.
sorry,
Uh, previous page.
uh,
Please scroll up.
okay.
Oh, okay. This one best practices. What are the best practices in everywhere you see?
Best practices.
Why you this added? Why the best practices mean? Why this is the consequences?
Where
What does mean best mean you have to practice from that? What is this consequence or what?
best practices is like this is how we practice it, which is the best method. Okay, that is called best practice. Let's say uh, we will be eating with the right hand. Okay, that is the best practice. So you can eat with left hand also, that is not a restriction, but the best practice is you will eat with right hand, that's it.
Oh,
Okay,
okay, that's why it is there.
yeah, that is the definition of what are the best practice that we follow. Okay, so then you have something called read speed versus write cost. So whenever you want to read, okay, which will have a benefit here. Okay, so whenever you are selecting, the queries will run faster if you are having a read. Okay, if it is reading, where, join, order by, group by, okay, which will speed up. Okay, which will do a efficiency also if you are enabling or sorting or doing a deduplication your data. Okay, which will read very fast. It will reduce your CPU and input output usage, so that it will reduce the load on your hard disk and your CPU. Okay, this is the benefit of read. Okay, now if you are doing a indexing here properly, if you are not doing indexing, okay, your insert, update, delete will become slower, because it needs to keep on updating it, or it needs to keep on inserting or deletion. That is what your indexing will be doing. Okay, it will consume your extra disk space. 20 to 50% it will be doing the indexing. Always it will be running. The indexing service can cause log contention during heavy writes. Okay, log contention means multiple people trying to write it. See, your indexing service, it will be running 24/7. Okay, so if you are writing always, then you will have performance hit. So only you select when you required it the most, or else you don't index it. Okay, that is the one liner for indexing. Okay, so when you want to use, okay, this is your best practices. Okay, when you want to use, okay, so you use it when there are classes here, where, join, order by, group by. Okay, if you are having small tables, don't use it. Less than 10,000 rows, don't do indexing. Sequential scan is faster than indexing. If you want to read sequential data, you go ahead with sequential scan. Don't do a index. Okay, so if you have foreign keys, highly recommended. Okay, you just you are querying heavy read heavy workloads. So if you are reading it heavy workloads, then don't do index. Okay, and then you have highly selective data. It is not a overall data. If you are not selecting overall data, if you are doing overall data, then you can select the index. Okay. If you are very selective, then don't do indexing. Okay. Then you have heavy write traffic. So your database or your application is heavy insert and updation. Okay. Let's say you have a health records. Okay. Where there is no deletion, only insert and updation. Okay. Or else you are having some railway reservation where there is a heavy read, insert, update and delete. So PNR number, okay, every 1 week you need to delete that, something like that. Okay. So you will go ahead with non-indexing. Okay, you will avoid all the indexing. So which are rarely used. Columns which are rarely used, you will not do that filtering or indexing. Okay. So composite index, these are the best practices. Okay. So better if it is order, your orders matters. Okay. So leftmost, then covering all that. These are all the example of composite index. Okay. These are the best practice if you want to do a indexing of the composite index. Then you
Filtering and indexing is same thing.
sorry.
I'm asking filtering and indexing is same thing.
Filtering is different, indexing is different. Okay. Indexing is I will select everything, I want to know each and every detail.
Yes, yes.
Filtering is I want to see only 10, 20, 30, 40, 50. That's it. So if my book is 500 pages, I will read only 10, 20, 30, 40, 50 page number. That's it. That is filter. Index is I will capture every page. That is index. Okay. So now how you want to verify the index usage? This is the query you want to use the index, how much you are using it. So MySQL, it will explain select. Okay. If you do explain select, then it will give you the index, how much you are using index, how much it is being used. Okay. How much it is not used also you can see it. Okay. With that you can tell, okay, whether you are having a performance by using index or not. Okay. So this is your reference when you want to use it, when you want to use which index, recommended indexing. Okay. This is your quick reference, which one to use when. So now you have something called subqueries here. So we will cover this topic. Okay. And then you have something called advanced topic. After that we will have modeling. Okay. Where you will be doing a designing of the database. So this we can cover it later. Okay. You don't have to do the designing here.
Maximize this PDF.
Okay. So you don't have to do designing part. Designing part we can later come once you do the practical. Okay.
Okay.
Okay. This is when you are you want to create a business case. So this is all the design part. So what are the primary keys you want to use, foreign keys, your composite keys, all that you will be designing. This is the design phase. Okay. Normalization, data modeling, then your
Manipulating.
sorry.
Data manipulation is there.
Where it is? Data
No,
modeling.
No, manipulating. I'm asking, is it there or not?
So that is inside the query. So this is your design. Okay, you will be designing this.
Oh,
Okay, that is your querying. That one is you are doing a modeling here. Okay, like how your data should be present. Is it rational or irrational, or it is not at all relatable? Okay, so you will select, okay, what database you can use. So relationships, okay, consistency. Then you will check, okay, what type of content you are having. Okay, so you will check what is your use case. So are you using it for financial, okay, or you are using it for content, your website. So the customer will tell, see, my content is I will pick the data from Facebook and Twitter and the X, Twitter. Okay. Then he will tell, okay, you don't take rational database, you go with NoSQL. Okay. So somebody
what
will
is a
tell,
NoSQL? I don't know. NoSQL. Sorry.
that is one type of database model. Okay.
No, I know my SQL, but what is NoSQL? No, NoSQL is not in Dex. I have no idea about. Sorry, please you have to know about NoSQL definition.
NoSQL database. Okay. Let me open
No,
up.
what SQL I know, but what is NoSQL?
NoSQL means there is no rational in the data here. It is
Oh, okay.
scattered here. There is no structured data. That we call it as NoSQL.
Oh, no definition.
Okay. It is just you are putting the data. Okay. You are just giving the data and you are storing. Okay. Store how you read. Okay. Store once, join many times. Okay.
Okay.
So your golden rule, see, once I store it, I can pull the information anytime I want. Okay. Here you I will store how you read. You just store how you want to read. See, I have a smart watch. Okay. So this one will be throwing the data. That's it. You capture the data, you store it in the cloud or in wherever means you want. Okay, now I will be talking. Okay, you take my data, YouTube live stream, you capture this data. Okay, so that is how your NoSQL will be. Okay, it will be capturing the data from multiple streams. So that is your NoSQL, which is non-rational. You can call it as non-rational database. This is your rational database where you have logic. Okay, so you
Do
can
it
see,
later.
you can see this here. Okay, uh,
And we do it practical also in which sorry
okay,
in database design and modeling.
okay. Let's say we will cover this. Tomorrow what we will do, I will cover the subqueries. Okay,
Yes, yes,
subqueries, then advanced this topic. These two topics I will cover. Okay, I will not cover this database design, security, connectivity, and advanced toolkit. Okay, so these four topics I will cover once you do the practical here. The phase 2 you complete it, you complete all these practical. After that I will tell you all these other topics, design, security, and connectivity.
okay,
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 so till now you will get all fair idea on what to use these tools.
yes,
Then you can do the practical. After that I will tell you, okay, how to do the backup here. So once you do the backup, once you do the design all, so how you want to take the backup, the complete backup, how you are copying from your database from Mumbai to Chennai, how you are doing a multi copy. Okay, point in copy. Okay, disaster recovery. So let's say one database goes down also, how it will work, all that functions, you will get it here in phase 3, okay. So you will have one more drill for this, how to do the database disaster recovery, okay. So once the data goes down, how you will be doing it. So this I have created one, there is no graphical here, I will get it done, okay. So then once this is done, you will do performance optimization, okay. Your performance of the database is very dull, then you will do the indexing here, okay. You have indexing here. So you will point it out what indexing you want to use. You will analyze all this. This will be one more project.
Again indexing, because it wasn't.
Yeah.
It was done now. We have done previously indexing again.
Yeah. Indexing. This will be practical on the
Oh.
real time. You need to analyze. Okay. So you will. I will give you some exercise. So you need to apply, okay, how you need to do all that. You have to analyze and you have to come up with the idea, okay, what index will apply here, okay. So this one you get in practical in phase 4. This will be your advanced level, okay. Then this will be your HA part, okay. So the database, it should be running here, one in our premises and one in cloud, okay. So one in working here in Mumbai and one it will be working in Chennai. Both it should be working at same pace and same speed, okay. This will be one project on the HA, high availability, okay. Then you have failover cluster. So let's say if your database fails, what happens, how it connects, what is the protection, all that concepts. So then you are automated. So if something goes down, so how your automation tools will work, okay. After that, last you will have this project. So your project, you will act as a lead DBA and this will be your project, okay. So phase 1 you will do the design part, and then phase 2 your security model, how your application role and your administrative role, who will be the DBA, who will be the lead DBA, all that you will segregate roles here. Then you will have backup strategy, okay. So if Mumbai goes down, how long it will take to recover from Chennai or Mumbai or from Delhi. So this is your backup and recover, RTO and RPO. Then the performance here. So how you are going to do the performance, okay. Then last you will do the documentation. So how you will document it. So who will be the first one to call, second support, third support. So how you will be contacting, all that you will present it in a documentation or presentation, okay. You will give the executive summary, okay. So this will be your phase 1. This is how your database will be. Then phase 2 your security. Then phase 3 this is your backup, okay. And then performance, and then your contacts, who will be contacted. This will be your last project, okay. Capstone project where you can put it in your resume like I have worked on this, okay. So then we'll do it tomorrow on this 2, and then Wednesday we'll start the practical year, okay. We'll see how it will go on the practical part, okay. So this I will share this one also. See, I don't want to spam now and then, that is why I will share the final version. So still this is 70% completed. So I will add 30% of the content again in this. Then we'll give you the content whenever I get updated here. So this I have done almost 70%. Okay. So once I am done, you will get it at least 600 pages document. Okay. So that it can be easier for you to refer it. Okay. So that's it for today. Tomorrow we'll see that 2 chapters. We'll finish it off. Then we'll start the practicals. Okay. Thank you.